So descriptive statistics, type of statistics, and this is in contrast to inferential statistics. We'll get to. It's just different ways of describing your data. So this is the first. This is the first step in your data analysis. There's a few reasons for that. Sometimes that's all you need. So there's situations where all you need to do is describe the data, and you're done. That's all we need to know. Sometimes another reason we'd start with that, I should say, is because it helps us detect outliers and errors in our data. It lets us know if there's an error might be you're entering the ages of children in a kindergarten class that you're doing some study with, some cognitive psychology study or something, and you do your descriptives and you see that someone has an age of 65 and you think that's a really old kindergartner. And it turns out that it's a mistake. Someone just typed it in wrong when they went in the computer, or maybe there was a 6-year-old and a 5-year-old and they didn't hit tab or something in the spreadsheet. So it's great for that. And then the last one would be it lets us know if our data meet the assumptions for more advanced statistical analysis. So there's different techniques we'll do next week and the week after and the week after for the next few months. And those rely on assumptions. So we say, well, we can only use this technique if the data look like this. And so the descriptives sort of let us know if we can move forward or maybe which technique we need to use. If the data are this way, we'll use technique A. If the data look a different way, technique B. A lot of people skip over the descriptive statistics, which is really too bad. They'll make a lot of mistakes that way, so don't do that. Okay, we'll go ahead and pause the video here and we pick up with the next one. We'll talk about when we need to use descriptive statistics only and when we need to use inferential statistics. The basic difference between descriptive statistics and inferential statistics is who you're really interested in. In both cases, you take a sample, you take a group of people or whatever you're studying, unit of measurement, and you collect data on them, and you take a look at that. We just need descriptive statistics. All we care about is that group. With inferential statistics, we don't really care about that group so much, rather the greater population they represent. So some examples where descriptives would be fine. How many students voted for Billy in the class election? So it's an election. There's however many kids in the class, and we just want to know if most of them voted for Billy, where their criteria is. We don't care about anyone other than those students. That's all that matters in this case. So if 51% voted for Billy, then Billy wins, and we don't really care what students who aren't in his class who they voted for, who they would have voted for. It's irrelevant. In contrast, in a presidential election, well, before the election, there's all kinds of polls that are taken. And so in the US, they might survey 1,000 people, but they don't really care about those 1,000 people. We care about the hundreds of millions of people that they represent. So we want to make inferences about millions of people based on 1,000. The average number of 4th and 5th graders to attend Sunday school during second service. Again, we're just describing. How much did tithing decrease during the summer? We're just describing. We're interested in those particular months. What types of ice cream did the ice cream man sell the most of in last August? Again, these are specific instances we care about that group at that time. We're not trying to make inferences about any other groups.